Back from Thanksgiving break. Hopefully you guys had a chance to relax, catch up on some sleep, enjoy good food with family and friends. We're back here with some more related rates. So let's take a look at the first problem. Okay, here's what it says. A spherical balloon is being filled with air at a rate of 5 cubic centimeters per second. What is the rate of change of the radius of the balloon the instant the surface area is 36 pi centimeters squared? On these particular problems on the AP exam, they will give you volume and surface area equations for the sphere. So they give us those two equations. The volume is 4/3 pi r cubed, the surface area is 4 pi r squared. Okay, so once again, these problems can be a little overwhelming and scary at first. But what we want to do is we want to make a list of what we know, make a list of what we need, find an equation to derive, right? We have two equations here, right? So we're going to have to figure out which one are we going to derive. And then the other equation, sometimes we need to solve for a missing variable of some other kind. Okay, so let's make a list of what we know. This problem's a little bit tricky because we see this rate of 5 cubic centimeters per second, but it doesn't tell us specifically what that is. So we have to use some reasoning skills here. Right? It says a spherical balloon is being filled with air at a rate, so we know it's a rate of 5 cubic centimeters per second. First off, we know that 5 is going to be positive because we're filling it with air. Right? It's not being air let out, right? That would be negative. So the question is, what is that we know? Well, our variables here are volume, radius, and surface area. Right? Is the volume changing at a rate of 5 centimeters cubed per second, or is that radius, or is that surface area? Well, a couple of things can help us here to identify which rate this is. The first thing I'm going to look at is the unit. I know that the unit there is centimeters cubed per second. First off, that per second tells me it's a rate. Centimeters cubed. Which of those things, volume, radius, or surface area, do we measure in cubic centimeters? Well, the only one of those that we measure in cubic centimeters is volume. Also, we can think about, right, this is the air filling the balloon, right? Filling the balloon, taking up all that space, in that three-dimensional space inside, is clearly leading us towards volume. So what we know right away is dV dt equals 5. I don't have to write units, but I do, if I have a pi, I really need to make sure I write that. Okay, so that's one of the things I know. Now it says, what is the rate of change of the radius? That's my question, rate of change of radius. So right away in my need column, I need to find dr dt. That's going to be my goal. But it says, what is the rate of change of the radius of the balloon the instant the surface area is 36 pi? Okay. So that goes in my no column. So it's 36 pi centimeters squared. Is that the surface area dt, or is that dV dt, or is that dr dt? Or is it the surface area, or is it the volume, or is it the radius, right? That right there is simply the surface area, right? It's not a rate because it's not centimeters squared per second. So that's simply the surface area. So I know that the surface area equals 36 pi. That's all I can really get right now. Okay. Now we might need to do some more later. Spoiler alert, we will. But that's all that's explicitly given to us. Next, I need to find an equation that I am going to derive. Now, when we do this, we can look, right? We need dr dt. Well, r shows up in both of my equations. So which one do I use for my derivative? Well, look back at the no column. What we know is dV dt. So we want volume to be the equation that we derive. So the equation that I'm going to derive is my volume equation. When I derive this thing, I'm going to get dv dt out of it, and I'm going to get dr dt out of it with some other stuff. Oops, that should be a cube. Okay. So that leads me to choosing v as my derivative equation. Okay. If I chose my surface area equation, I'm going to get dSA dt and dr dt. And I don't know the rate of change of the surface area. So that doesn't help me very much. Right? So I have to use this one to be my equation to derive. So let's go ahead and do the derivative. The derivative of v is simply going to be dv dt. That's going to be easy. Now how about the derivative of 4/3 pi r cubed? Well, again, 4/3 pi, I don't need a product rule here. 4/3 pi is simply a coefficient. So I'm going to use the power rule. I'm going to take my 3 and multiply it by 4/3 pi. The 3's are going to cancel. And I'm going to be left with 4 pi. And now I have to reduce my power on my r by 1. So I get 4 pi r squared. But what do I need to always multiply by? Right? Don't forget, chain on your dr dt. Okay. So when I look at this, right, I know dv dt. 4 and pi are constants. I don't know r or dr dt. Okay, it's okay that I don't know dr dt because that's what I'm trying to solve for. But I don't know r, right? So I call this the wrinkle, right? This problem has a wrinkle in it because I need r to solve my equation, but I don't have r, right? Well, if we get a wrinkle, don't worry about it. Just think about what haven't we really used yet? Well, we haven't used that surface area equals 36 pi. That hasn't been used yet. Well, if you know the surface area of a sphere, you can find the radius of a sphere by using that other equation. Surface area equals 4 pi r squared, right? So I need to figure out r so I can solve this problem. Well, I'm going to get r using this equation, right? If surface area equals 4 pi r squared, but the surface area we know is 36 pi, I'm going to set those two things equal to each other, and I'm going to get 36 pi equals 4 pi r squared. So I do need to use that equation. I'm just not using it for my derivative. Now solving for r, I want to divide both sides by 4 pi. Okay, my pi's cancel out, which is nice, and I'm left with 36 over 4. 36 divided by 4 is 9. So I get 9 equals r squared. Now I'm going to square root both sides, and I'm going to get 3 equals r. So I'm going to add that to my know list, because now I know that the radius, right, if the surface area is 36 pi, I know the radius had to have been 3. So now I turn this question mark into a check mark. Okay? Now be careful. We're used to solving for this one and knowing all of these, but that's not the case here, right? This time I actually know what dv dt is. dv dt is 5 equals 4 pi. Now I know r is 3, so I got 3 squared, and then I got dr dt, which I don't know, and that's okay. So sometimes your unknown is already alone, sometimes your unknown isn't alone. Either way, it's not a problem. So I get 5 equals 4 times 3 squared. 3 squared is 9. 9 times 4 is 36. So I get 36 pi dr dt. Now I want to solve for dr dt, so I need to divide both sides by 36 pi. So I get dr dt equals 5 over 36 pi. When you write this, make sure that pi is very clearly in the denominator. You can't have 5 over 36 and then write the pi out front. And the pi definitely can't be on top, right? The pi has to be on the bottom. Units now, my radius unit is a linear unit. I think I was using centimeters, yep. So I'm going to say 5 over 36 pi centimeters. It's a rate per second. And that's my answer. Okay. So there's a different type, right? This is a three-dimensional problem now, but we can solve it using the same steps. Find our know, find our need, find our equation to derive, right? We had two to choose from. Hopefully we chose the right one in volume. Right? Then we did the derivative and we realized that we had two unknowns, right? We had a wrinkle. So we fixed the wrinkle by using our other equation and our other known to find out what our radius was. Okay? It is very often on the test that you're going to have to do that wrinkle. Right? Just iron it out. There we go. Okay, next problem. I have one more problem, and then I'm going to be out of here. Okay, here's our problem. Two trains leave the origin station. Or as I like to say, two trains. Sorry, that was kind of cheesy. Okay, so we got two trains here leaving the origin station. Train A heads east at 40 meters per second, while train B heads north at 35 meters per second. What is the rate of change of the distance between the trains the instant train A is 30 miles east and train B is 40 miles north? I should say of the origin station. Yeah. So these trains probably did not leave at the same time. Okay, that's okay. We don't have to worry about that. What we might want to do here is draw a picture. Right? Sometimes pictures help. So let's draw a nice little picture here. Here's our origin station. And we have never eat soggy waffles. And train A is going east. So what I'm going to do is I'm going to draw train A. I'm just going to use a box and A. Train A is east. Which way is train going? Right? Train A is going towards the east, and it is also east of the origin, right? So train A is 30 miles east, but train A is also heading east. So it's east of the origin going east. It could be east of the origin going west, and this problem would be a little bit different. Or it could be west going west or west going east. It could be any of those things. So we have to pay attention closely to make sure we understand what it's doing here. Train B is 40 miles north. Right, so train B is up north. And train A is also heading north. So train B is going up. So let's think about this in terms of what we know. Remember, it's really important to distinguish between rates and amounts, right? Let's start with rates. What is train A's rate? Is train A rate 30 or is train A's rate 40? Well, which one of those two is a rate? Miles? Or sorry, I should change this to meters, my bad. And I'll change this to meters. Since lowercase m means meters, not miles. Okay, so train A is 30 meters east, but train A is traveling at 40 meters per second. Hopefully you know the meters per second is the rate, right? Rates always are divided by time. So train A has a rate of 40 meters per second. Okay? So I'm going to say dA dt. Some more room here. dA dt is equal to 40. Now I want you to think for a second, should that 40 be a positive number or a negative number? Well, here's where I need to be careful, okay? What we're forming here is we're forming a right triangle. And I want you to think, is that distance A, right? This is the distance A right here. Is that distance A getting bigger or smaller? Well, since it's heading away from the origin, it's getting bigger, so it needs to be a positive 40. If train A was heading towards the origin station instead of away from it, that distance A on that right triangle would be shrinking, therefore I'd use a negative number, right? That'd be like decreasing. So dAdt is 40, while A is 30. Similar analysis of train B. dB/dt now, the rate of change of train B is 35. Once again, it's heading away from the origin, so this should be a positive number, 35. Train B's position is, what did I say, 40? So here's my A, here's my B. A and B are those distances. And what I want to figure out is the rate of change of the distance between the two trains. Well, the distance between is always a straight line, so it's right here. The question is, what letter should I choose? Well, since it's a right triangle, I'm going to choose C to be my distance, because I like using A, B, and C on right triangles, with C being the hypotenuse. Okay. What I need to do now is find an equation that relates A, B, and C. Now there are two options here. I'm going to show you the easy way first, and I'll show you another way you can do it that's a little bit harder. All right? We can relate A, B, and C using the Pythagorean Theorem. The three sides of a triangle always relate nicely with A squared plus B squared equals C squared. Okay, so that's going to be my equation. With right triangles, I'm always going to look to see if I can use the Pythagorean theorem, right? I want to do this because I need dc/dt. I need the rate of change of the distance between the two trains. So I'm looking for dc/dt. Okay, so that's all I explicitly know. But do we anticipate anything else that should go on our no column? Well, when I do the derivatives here, I'm going to have A, B, and C show up again, right? But I don't know C. And it might help to know C. So I'm going to anticipate that and solve for C right away. Now, with right triangles, always look for Pythagorean triples. You guys who had me for geometry, you know that I hammered you on Pythagorean triples. We're going to see them all the time. 30, 40 are the two legs. What is the hypotenuse going to be? We should know it's 50 without doing any work, because 3, 4, 5 is our most common Pythagorean triple. If you don't see that, use this equation right here to solve for C. 30 squared is, what, 900? 40 squared is 1600. 900 plus 1600 is 2500. The square root of 2500 is 50. But if this was a no calculator problem, doing the square root of 2500 would be a pain in the butt. Okay? So they're gonna want you to know your Pythagorean triples. 3, 4, 5, 5, 12, 13 are the most common, and those multiples of those. Okay, so now I can go ahead and derive this equation. So I'm going to do the derivative of everything. I don't have any product rules or anything like that. So I'm just going to go through. I'm going to get 2a, and remember to tack on dA/dt, plus 2b dB/dt equals 2c dC/dt. Now, one thing that I want you to understand is that when you do this equation and you derive it, notice what shows up in every single piece of this equation. Well, the number 2 does. I'm just going to go ahead and divide that 2 out in all 3 spots. This is a good technique to use on no calculator. It just makes it easier to calculate this all out. So here's what I have. I have A times dA/dt plus B times dB/dt equals c times dc dt. If you don't cancel out those 2's, it'll still work. You'll just need to reduce on your last step. So a is 30, dA dt is 40, plus b is 4. Yeah, 2 40s, that's okay. B is 40. dB dt is 35. And that's going to equal C, which is 50, times dC dt, which is what I'm trying to figure out. Okay, 30 times 40 is 1200. That's pretty easy. 40 times 35. Well, 4 times 35 is what? That's 20, 12, 140. So it would be 1400. So I got 1200 plus 1400 equals 50 dC dt. 1200 plus 1400 is 2600. And then I just have to divide by 50 on both sides. I'm going to cross out those zeros. Now I know 260 divides by 5. 5 goes into 26 5 times. 5 goes into 10 twice. So I get 52 equals dC dt. And it's a rate of distance, so that would be 52 meters per second. So those trains are moving apart from each other at a rate of change of 52 meters per second. Now the other way you could have done this is you could have said the square root of a squared plus b squared equals c. That would have required a chain rule to do. I'm running out of time, so I'm not going to show that here, but we can talk about it in class if you want. Still get the same answer of 52 meters per second. All right, that's it for today. Have a good day. 2 trains. Bye.